Hey, what is up guys, and welcome back. So today we're going to be building a premium setup, and there's a couple of reasons for this. One is I haven't built a quad in such a long time, and also I want to go through all the steps as quick as possible and as efficient as possible while teaching you as much as possible, especially if you're new here. Now let's talk about some of the components before proceeding. Now I'm using the 3BB frame, which I'll have linked down below. Everything here will be linked down below if you could check those out. Those greatly support the channel. Now for motors, I've decided to use the iFlight Xing or Xing motors. These are the 2207 2450 kV. I really like the 2207 size and a 2206 size, so I went ahead and went along with these because I also want to test them. Now they're really nice motors, but I still don't know how they perform. For stack, especially for ESC, in my opinion, an ESC is what's going to dictate how good your quadcopter will fly and if you'll run into issues. There's other things as well that'll do that, but the ESC is one of the most important components here. And for ESC, or should I say stack, I've decided to use the brand new Kakaute stack, the Kakaute F7 V2. Now, this is the flight controller. The ESC, I'm using the 4-in-1 metal ESC. Now, these FETs on board are absolutely phenomenal. I have done testing on the single ESCs, however, I have not done noise testing on this one just yet, and I really want to stick it into the build, take it out for a flight, and then do the noise testing on. So for ESC, this is what I'm using here, and I think it's rated up to 65 amps, and again, it's linked down below. Go ahead and check it out. Now, for flight controller, it's also the Kakaute. This just comes as a combo. You could purchase it as a combo if you wanted to. I'm using the STM F745 here. Now, this is the latest microcontroller unit. It's the fastest microcontroller unit. It's not the it is the top fastest, but there's two versions of the F7s. There's the small one and the bigger one. The bigger one is this one. It has more available pads or ports, you might say, and it also has more memory and more RAM, and this is going to come into play later on within about a month or so time, which I'll be installing NeuroFlight on. And this is where the AI removes the PID controller from Betaflight, and there's going to be updates on that very soon. This is one of the quads. This is one of my testing setups for that after we test all the components on board with Betaflight. So yeah, for flight controller, I'm using Kakaute F7 V2. This is really nice. It also has a sensitive gyro, and it's soft mounted externally, and this has proven to work absolutely phenomenal. Not only that, we have a bunch of UARTs, we have a barometer, OSD, everything you would want in a quadcopter is in this guy here, so that's something really nice. For motors, we already came across the motors. Now for VTX, I'm also going to be using the Kakaute AT Lateral V2 just because I got this stack, and I'm going to be installing this, and it's going to make it as easy as possible for us to install because this thing is really well thought through and everything. All we're gonna have to do is just solder a couple things like motors, these wires for the VTX on the flight controller, the receiver, and just the camera wires. That's all we're gonna have to do. The routing from the ESC to the flight controller is already done via this connector right here, so that's just gonna make everything super simple and super easy for us. As you can tell, it's right there in the ESC, and I just routed it under here to come to the flight controller. And what happens like this, now you give power to the ESC, and the ESC will give power to the flight controller, and the ESC will also give each signal or each motor's output signal to control each motor through this connector, as well as telemetry and the battery voltage. So we really don't have to do anything, just plug this wire in, and this is what really complicates a lot of things for people here. So that's something really nice. What else do we have? Also, this antenna here, I forgot what company this is from. It's ZRC. I'll have a link down below. I got this from Banggood to test, so we're going to be testing it. Hopefully it's good. Time will tell. All right, so the first thing I want to do here is I want to start by soldering up the motor wires, and I'm going to go ahead and remove the flight controller, which is just going to remove just like so. Now, something you need to take a note with an ESC is you always need to know where's the motor orientation. You always want motor 1 to be on the back left here, especially on 4-in-1 ESCs, because this is the default Betaflight configuration. So we have motor 1, it says M1 right there, motor 2, which is right there, and we have motor 3 right there and motor 4 right there. So that's perfect. So when we come in and bring our flight controller, we should find the arrow also. They all have arrows, and make sure it points forward. So this is going to be the back for us then. And this way we don't have to, this way you'll know your quadcopter is going to fly on default settings. So keep that in mind. That's very important. All right, so I'm gonna go ahead and just remove everything off the table and let's start soldering. All right, guys, so first things first, what I do is I usually like to put the solder on the Nylon ESC first. However, with this one, you need to take something into consideration. The holes here are metal and they're not grounded. It's inside these little lines. You'll see some metal, and your solder, if you're doing this without having the standoffs off, might touch that hole. That's fine, because each hole is connected with one of the phase of each corner motor. So what you want to do always is double check. For example, they're stating just don't use metal screws. However, I used metal screws, but what I did instead is I kind of insulated them with the Maytech rubber grommets here, so the metal screw doesn't touch the frame. Because if that were to happen, if the metal screw was going through the whole frame here, then this motor, this motor, this motor, and this motor's phases will all be connected, and boom, it's gonna catch fire. So just use plastic standoffs. That's what I'm trying here. So just be extra careful and use plastic standoffs. Now let's start soldering here. I usually set my soldering iron anywhere between 380 degrees Celsius to 400 degrees Celsius, usually on thicker pads, especially for the grounding of such 4-in-1 ESC. The ground pad is all over the place and it has a lot of copper, so you're gonna have to like basically heat up all the board. So the hotter the temperature, the better you can put the solder down, because it can be quite difficult sometimes if your temperature is at pretty low. So you might want to increase it just really quickly to 400, even 450 sometimes, but just for ground pads. For example, the Maytech F405 wing, I think, not F411 wing, that one is really nicely made. It has a lot of copper in it. And the ground pads were always very difficult to solder because the heat dissipates throughout the whole board because the ground is just everywhere. This is how PCBs are basically built, and yeah, that might be useful or helpful sometime for you. Hopefully sometime in the future if you run into that issue. Now currently I have it set to 386, and I'm gonna start by soldering up, or just adding solder to the pads here. All right, so we're gonna do a couple together, and I'm just gonna skip the rest because it's basically the same way. And if you were curious or new and just wanted to see the type of technique being used, this is a really nice way just to give you an idea. So let's go ahead and do that. Now, sometimes you might be afraid that this right here will bridge to the MOSFET. It's okay, because usually those are connected to the exact phase here, but not always. For example, if we possibly bridge this corner one to this one, just try not to bridge them. But if you do, it's kind of okay sometimes. That's what I'm trying to say. But the end result, try not to bridge these, because then you know you're just gonna burn and be like, oh my god, they said it was the best. It's all bullshit. I don't trust anybody. I don't believe anybody. So yeah, just keep that in mind, because these things, it's so difficult to really know that you have an issue here. And it's really nice of some companies that usually most of the issues on these are user fault. You know, I've even burnt a couple things, you know, doing this stuff, and it was my fault. But even for me, it's sometimes even difficult to know that it was actually your fault or not. But, you know, like 90-80% of the time, it's usually the user's fault while building, or just did something wrong. So just keep that in mind. Now, this ESC is also recommended you add low ASR capacitor. Now, I recommend you add low ASR to capacitor to any 4-in-1 ESC. The amount of space or real estate on these boards doesn't allow them to have just good filtration most of the time. So, and they usually nowadays come with 4-in-1 ESCs. I mean, come with low ASR capacitors. So try to get a good one. Panasonic, Rubicon, Sanyo's seem to be pretty good. I haven't done much testing on them, but they seem like they're holding up pretty well. So, and if you don't know where to get some, I'll have some linked down below. However, this ESC does come with a low ASR capacitor. They do provide you with a Sanyo low ASR capacitor here. And with this, you'll be able to run 6S if your heart desires, but then it comes down to your motors after that. Now, my motors, I don't think they could run 6S, but for me personally, I'm not the 6S type of guy. I still like my 4S quads, and I do have a couple 6Ss, but it's just much scarier and much more expensive in my opinion. Also, something to take note of here is you do not want to bridge these together. If you do, you can say bye-bye to the ESC and or your motor, or possibly everything else. Now, also, you see this little line here, this little bridge. You can add solder to it, and that'll improve the current flow even more. But if you're not that experienced, just don't touch it. For me, I'm just not going to touch it right now. So we're going to add just some solder to these pads also. Okay, so right now, this is the ground pad, the power pads. Usually on ESC power, right now I've increased it to 450 degrees just to make my life easier on these pads, and it just makes everything a little bit much easier, because it can be quite challenging and quite annoying to get the solder to stick. There we go. All right, so that's looking really good. So now what I'm going to do is I'm going to just skip over this part, which is just stripping the wires and also adding solder to the wires and trimming them to length. And then I'll come back, we'll solder one motor together, and then we'll take it to the next step after that. All right, so let's go ahead and set up our first motor. Now what I've done here is I've trimmed them to length, stripped the wire, then I twisted the strands, and then I added solder to each wire. This is the most time-consuming part of a build usually, or extending wires sometimes. Sometimes people have to extend wires. Now I recommend you get some sort of a tweezer or apply, or just a tweezer, like a ceramic tweezer such as this. I'll have some link down below if you want a ceramic one like this one. I accidentally broke it the other day. But yeah, it's really good to have this because the wire does tend to get really hot. And while you're soldering such thing, you don't want it to move, because if it moves and you get a really bad solder joint, it's not the end of the world. Everything will work still just fine. But, you know, if you're paying this much for a bunch of components, you possibly want them to operate or just to run at optimal performance. And that's the whole idea here. So there we go. We just got one in. And now, as you can tell, I'm not really stressing the wire orientation. Is because I'm going to switch it later on in the BL Heli 32 software here. So as you can tell, now I'm going to grab my second one. I'm just going to hold it up top. And so there's also a really nice technique is to keep your forearms rested on the edge of the table. This gives you a really, really stable hand and just better grip and just better accuracy. And this is what you need here, because and you also want to make sure you always clean the tip, because if you had any solder just drop on top of this like a small solder splash, then you can say bye-bye to everything. So just be very careful. Take your time. You're not in a hurry. If you only had 1 hour, you're not going to finish it in 1 hour, especially if you're new. Just do what you can and come back and finish the rest. And also something else that's really important is don't add solder to the wires above your components, because solder might fall and you might get a blob somewhere so tiny that you can't see, but it actually creates some sort of a bridge, which can be really devastating and very bad. All right, so I'm just going to skip over the rest of the motors here, and then I'll be right back. All right, so now we have the motor wires connected, and obviously they're not really clean right now, but that's totally fine. We can just put tape on them later on. Now let's take a closer look. So something that's very important that you should take note of is double check if any of these are touching each other. If they're touching each other, then you have an issue. Also, another thing you can check with this ESC, and it's actually kind of a must, is with a multimeter, put it in continuity mode and touch the corner pads of each of the ESC. If it beeps, then you have something that bridged from a metal screw if you're using a metal screw. If you're not using a metal screw, then you have nothing to worry about. But if you are, keep that in mind, because that's how you'll know if the corners are bridged. Even if just two corners are bridged, then immediately take it off and replace it with a plastic or a nylon standoff. And that's what you should be using with this ESC. So also another thing that I'm planning on doing, and I will be adding, is a low ESR capacitor, but I'm not going to do that just yet. And the low ESR capacitors, and a lot of people ask, where do they go? Where do they go? They go exactly where your battery, your Xt60 is going to be connected. So just follow this Xt60, follow its wires. Oh, it's connected here. Then this is where that'll be connected. And how do you know what's positive and what's negative? Well, you could find the line. Usually all capacitors have some sort of a line, and that just means negative. So you put it with the black. And then the other side, which has usually nothing, it would go with the positive here. Now also make sure you add something to insulate these, because if they touch, then that's a nightmare for you. So keep that in mind also. Now the next step is we're going to grab the flight controller here. And now you might be like, okay, well, how is this ESC, if you're new, how's this ESC going to connect to the flight controller? Well, it's with this ribbon cable here, and it's actually connected right there. I just routed it from under. If you take a closer look, you can see it being routed through there, and it's coming out this side here. Now we need to find the front. I know this is the front here, and this is obviously going to be the back, and you can find the front. All flight controllers have an arrow. This one's right there, so it's saying that's the front. I'm just going to drop this guy right in. And let's go ahead and connect the ESC. Boom. And we're basically almost done now. That was the hardest part. Now all we need is the wires for the VTX, wires for the receiver, and wire for the camera. And we're done. It's just going to be that absolutely simple. So the VTX, what's really nice about the ATLotto, they do provide you with the wire you need. However, I've trimmed it here and I've already prepared it to just made it smaller, because they do give you a pretty long one and you really don't need a long one. But that's really nice that they do. What you can do is keep those extra wires that you cut off, like these, and these will come in handy someday on another build. I always do that. I keep all of these silicone wires here, for example, from the motors. Always keep them. They do come in handy. Alright, so now once everything is connected, we're going to wire it as follows. And the reason why I'm going to do it this way is because this is how it is default in the firmware. So for if you were to get the bundle, for example, with the AT Ladle, you can change the settings through the OSD. You can change the channel and the output power through the OSD, which is really nice. So you don't have to come and press just, one button, which takes a million years. Now this is set up as follows. To control this through the Betaflight OSD, it has to be connected to T4 here, which is this blue wire here. And also for the receiver, which we'll get into in a little bit, it's set up on UART6, and all of these things are set up so you don't have to even enable the ESC telemetry and any of that. Everything is pre-set up in the firmware, as if you're getting the bundle here. So that's something really nice. So let's go ahead and start here. Now what I want to do is, obviously this is for the VTX, so I need power, I need ground, I also need the video, because this is going to output the video from the camera and the OSD mixed together into the VTX. And I also need the smart port here to enable me to control the VTX. Now if you don't want to do that, you could just cut it off and you don't have to set that up. That's totally fine. So if we take a closer look here, we find that we have ground and B+. Those are the first two we're going to need. Ground is the black wire, B+ is the battery's voltage. So let's just add solder to those pads. Okay, and VO, which is video out, we're gonna need that. Okay, you don't want to hold it too long because then it'll just, the solder would seep through and it might fall to the ESC. Also double check after you do such thing. And now we're also going to need T4, and T4 is going to be this one right here. So I'm going to go ahead and set that up. Okay. All right, I'm just double checking if any dropped, but nothing fell through. Now I'm going to grab my, I'm going to solder the outer ones first, the inner ones first, because that makes it easier. Because if I were to solder the ground and I come in and try to solder the one behind it, it's going to be much more difficult for me. So I'll do with the B+, which is this one right there. And I'm just going to prepare it, as you can tell right here. Touch the pad and then just slowly use the soldering iron to guide that wire through. And now that's in nice and beautifully. And you also want to double check if there's any strands from the wire that popped out and is touching any other pad. If it did, then you're going to have to remove that wire and redo it again. And now we're going to do ground. So let's go ahead and set up ground here. Same method. I'm going to heat up the pad first, and then I'm going to bring in the wire and try to guide it through with my soldering iron tip. That's in. Very nice. And let's see if we can get it to focus. And there it is. It's in, nice and beautiful. Just make sure nothing is sticking out. Everything's looking good. Now we have two wires left, yellow and the blue. Yellow is going to be for the video out. So that's going to go on the VO pad, which is this one. Awesome. And next we need the smart port, which is going to be T4 as it's currently set up in the configuration. You could use anything you want if you know what you're doing, but this just makes our life way, way, way easier. There we go. One less thing to worry about there. All right, so now we have our VTX wires basically done. So our VTX here is complete. Now the next thing we want to do is we want to go ahead and grab our receiver. Now, if you're using iBus and or SBus, you can connect it to the same place. It doesn't really matter, but you're gonna have to change between SBus and iBus in the configurator. I'm hoping you do know that. I do have a video on how to set up iBus, so you can go ahead and search that out. Right now we're using SBus FrSky. Now any FrSky receiver that's SBus compatible is going to be connected exactly the same way. You just have to know your positive or your 5 volt, your ground, and your SBus wire. And as you can tell here, I have it pretty much set up. The yellow is going to be our SBus signal, and then this is going to be our positive 5 volts, and this is going to be our negative or ground. So I'm going to go ahead and start adding the solder to the pads here. All right, so first we have ground in the top corner right here. So I'm going to add ground just really quickly and just move out because I don't want the solder to fall through. And next to ground is 3 volts. So we're not going to need 3 volt because ours SBus is usually 5 volts all receiver. So we're going to take that one right there. which is above the 3 volts. And then the one next to the 5 volts here is nothing. It's not connected. So we need the one right above it, which is R6, which would be also UART6 here. So because R, you need an R because it's going to receive an input, because the receiver is going to tell the quad what to do here from your controller, which is you holding your controller. All right. And now let's see which way is going to be the easiest to start installing. I think I'm going to start with the back one, the top one right there, which is going to be the 5 volts. I think it'll just be easier for me to solder that way and not having to bump into any of the other wires and then just disconnect them by accident. All right. There we go. Our 5 volts in. I'm going to do ground now, which is that top one right here. Same method. I heat up the pad first, and then I move the solder tip out of the way, and then I slowly try to guide it. What I do is like I just heat up the pad, move it out of the hole, but keep it close to the hole, and start just doing this with the wire and kind of pushing the wire, finding the hole somehow. And it's usually working. I mean, just got to practice this and it'll work just fine. This is what I find to be, it's possibly not the best method, but I really like doing it this way. Keeps everything really clean, and I keep my wires very short, and usually it just falls right through. So now we have our receiver basically complete. Also, what's left is the camera. So I'm gonna go ahead and grab the camera wires, and I'll show you where those go also. All right, so here I have prepared the camera wire. Same way, I've just stripped them, or first cut it to length, stripped them, and then twisted the wire, then added solder to the wires here. Just this way, it's a lot better. Now, something about the length of this, you need to keep in mind. Now, you might be tempted to make it as small as possible, but that could be an issue later on, especially if you're gonna be debugging. For example, don't forget, this will be connected while the top is on. And if you don't have much space, this is all you're going to be able to do, and then have to try to reach in there in the field. It's an absolute nightmare. So try to keep just, a little extra. So right now I could possibly push this off to this much and then flip it over, and then I can work on this and easily take this out and put it back in if I needed to. So keep that in mind. You don't want it too long, and you also don't want it too short. So for our camera, it's these 3 right there. Now you have to be just very careful because it's really close to this here, especially if you're new. If you don't know how to solder one of these back on, then you might have a little nightmare on your hand. But what we're going to do is we're going to come in, set it up like this. For example, I'm right-handed, so I'm going to start with this one from my right hand coming in from just right here. So I minimize the chances of me bumping into the gyro wire here. All right, so and again, same process. I'm just going to make sure, just add a little bit. So there we go. I'm coming in off from the right here, just like that. And I'm making sure my hand is well rested, and I'm just taking my time moving in slowly. You're not in a hurry. This is not a race. So yeah, just leave the racing to the field and not the building. There we go. Beautiful. Okay. And again, don't add too much. If it's disappearing, then it's leaking. So just be very careful. Look how flat that looks. You might be like, oh, that's not much, but it actually is much. Once I put the wire in, it'll all grab into the wire. And yeah, it's okay. It still has some. Just make sure you didn't drip any below. If we take a closer look, we'll find VI, which means video in from the camera. Next one is 5 volts, which means 5 volts. And then the last one is G, which is ground. And let's grab our wire here. And usually they come color coded here, just about every single one in the market. Now I like to trim them about, I don't know how many centimeters or millimeters I would say. I keep them usually around 3 millimeters in length. I just find that to work good, but it's a personal preference, and just do what makes you comfortable. Now again, same technique here. We're gonna go ahead and heat up the pad first, and then just move the soldering iron to the back a little and try to find the hole. And that was beautiful. Next we have 5 volt, which is going to be the red wire. Just about everything is powered off from 5 volts from your receivers to your camera. VTX is usually battery voltage, and some flight controllers have voltage regulators, which is good because that gives you cleaner feed if it's done correctly, basically. All right, and now just the last one, and I think we should be done after this. Just the final setup of everything, and we should be good. Now, as you can tell, I'm having a hard time with the ground, because the ground is usually the hardest to solder to because it's all over the board. So you're basically heating up the whole board here while you're touching the ground. I need to double check that because I couldn't see because it was pretty far away from me. So I'm just double checking everything. Yes. And a nice technique is to twist the wire, especially with these silicone wires. It's really nice. It keeps them nice and clean, as you can tell right here. And I'll do also the same thing with my receiver wire. It just makes it really nice here. You don't have to twist it too hard. And there we go. So now we're basically almost done. So let's see, what else do we need here. Let's start by adding the standoffs now. So just a quick recap while I'm adding the standoffs here. As you can tell, this is all I had to solder, was this, and this. And obviously the motors and the battery. Now if you're using single ESCs, it's going to be a lot more soldering. For the ESCs, each ESC needs 3 motor wires and 2 power wires, as well as a ground and a signal wire. So the soldering process and the overall build complexity, or you know, it'll just be a little bit harder, especially if you're new. But this is going absolutely gorgeous. Now this is such a small frame that I'm gonna have, what I'm going to do with the receiver here is I'm gonna bind it, and I will stick it somehow behind the camera here, because that's the only space I have. So if we take a closer look here, let's go ahead and just set this up. Let's actually connect everything and just take a look at everything. We still need to put the VTX, which we still haven't done. We could easily do that. Now the VTX, I'm having to put it upside down, just like this here, because this is the only way it'll actually fit here. So another thing is always to keep an eye on your wires when you're closing a frame, especially if there's carbon fiber. You could rip the wire without noticing, or 2 of them, and while you fly someday, they touch each other, boom, your whole thing just smokes. So just keep that in mind and just be extra careful with that. Now, as you can tell, my antenna, my VTX antenna, which is really nice from Holybro, because this is very thoughtful. When they give you a VTX, they give you a 990-degree angle connector here, which is very, very useful. Because you know that's the only thing that actually will work for our quadcopters. Anything else won't really work. I'm gonna route this under the motor wire for right now. Plug that MMCX in, and if we turn to the other side here, we're gonna go ahead and connect the connector for the VTX. Okay. Tuck these guys in, and now we're left with the receiver. And I'm just gonna have to add some sort of tape or something for the motor wires here. But other than that, this is basically, it's almost its final form. Now I wanted to make sure I have some space left over for my zip ties to hold my GoPro mount up here. And I'm also going to design some mounts for this also, because this is going to be some sort of a testing quad on the channel, and hopefully if it flies good. And that's going to be tomorrow's video, because I'm taking this out tomorrow morning. I might build another quad today and take it out tomorrow, so we'll see that later on. So right now I'm going to figure out the best way to mount this and come back and show you, and then we'll take it from there. Alright guys, so this is how it looks complete, and let's go over what I did here. So I've just added some tape right there to the arms just to keep them in place. I don't have any black tape, and I actually can't find any in my city. They're all out. They've actually been out for a month, which is kind of weird, I would say. The antenna for the receiver. Now what I've done with the receiver is, if you take a look in there, that's a little green thing. That's a heat shrink around the receiver after I bound it. And what I did was, I was like, okay, well, I don't have any strong tape. I don't know how the weather is going to be like. So I just added just a small bit of hot glue on the heat shrink. And then I just stuck it right into the back of the, there we go, the camera right there. That's all I did, with the antennas pointing down, and I brought them off to the sides. And that's what you see here. They go off into the sides, into these zip ties. And then I just brought 2 heat shrinks because I don't have any long enough. So there's one that would hold it into place, and another one up top just to cover the tip of it, and kind of, it gets harder towards the end right here, even though there's nothing. So it does add some protection to the antennas here, because the antennas usually love to get ripped off. So that's one thing I did here. And that's it. Yeah, and just one more zip tie that I've added for the pigtail here for the SMA. For the MMCX to SMA. Did you see how it was routed? I just have it routed through there to the side, and then this, just so it doesn't catch, or the propeller doesn't cut it off, I just added a really tiny zip tie here right there, so it'll just hold it into place. And this will break easily in a crash, so I don't have it won't, you know, it'll take some of the force, so it wouldn't break this off or break something else off. So it's a nice little addition right here. So that's why I set that up there. And overall, this guy is complete. So let's plug him in. I have no idea if it'll catch fire. Oh, and by the way, remember this, where I said this is the must-have thing ever? Well, it not only acts as a power supply, but it can also be like a smoke stopper. The pass-through mode in the power supply mode, thanks to one of my subscribers or viewers, he commented down below, and basically it just passes the voltage through here, whatever battery you put, and you can set a current limit. So if you set a current limit of 2 amps, nothing is burning. It'll just hit 2 amps, keep restarting, and you know there's an issue there, and you can go ahead and debug it. And I'll probably show that in a later video. So overall, I have a link to everything down below. This has been it was a really challenging build, to be honest. Before I started the video, I really had to figure out how I'm going to fit this stack here, but this is a super premium high-end quad right now. I don't know how the motors are going to perform. I don't know the video quality of this camera, even though I've latency tested it, and I forgot what the latency test was on this. So yeah, it's going to be pretty interesting when I take it out for a flight. It's looking really nice. It's a bottom mount, and I'll be designing some 3D printed parts for this soon for GoPros and some action cams, because I got a bunch of new cheap action cameras I want to review on the channel. And well, that's it, guys. I really hope you guys enjoyed it, and let me know what you guys think down in the comment section. Go ahead and check out the links down below. Those greatly support the channel, and I also do have a Patreon. If you can join me there, that would be great, and I'll see you in the next one. Peace out, guys.